Hello students, this is Dr. Munir Omar with CS222 Database Management Systems. In a previous lecture, we studied about the transactions and transaction management. Today, in lecture number 50, we will study about the concurrency control. This topic is related to our previous topic. Actually, in this topic, we will study about the concurrent transactions and their management. These are the contents for our today's lecture. First, we will look into our previous lecture, which was about database transactions. Then we will start our today's lecture with concurrency control. Then the scheduler, and inside scheduler we have locking methods. After that, we will also study the deadlocks, and we have one optimistic method for concurrency control that will also be studied. And at the end, we will study about the database recovery. All these are associated with concurrent transactions, and all these come under the concurrency control. So in the previous lecture, we studied about transactions or database transactions. Transaction is a logical unit having two or more statements. If we have some statements that could be used to perform an operation in a database, then those statements can be combined in a logical unit, and that unit is called transaction. The most important thing about transaction is either that transaction must be executed completely, or it must be rewarded, or it must not be executed. Simply we can say that if there are 5 statements, then either these 5 statements in a transaction must be executed, or none of these must be executed. We have 2 statements for transactions. These are commit and rollback. Commit is used to make all the changes in the database permanently according to the statements inside the transaction, and rollback statement is used to roll back or revert all the executed statements or some of the executed statements in the transaction due to some issues or errors. We also studied about the transaction log for recovery, or for rolling back, or for keeping the track of transactions. The database management systems use transaction logs. These logs are databases, and these keep all the records about the multiple transactions and their statements in the databases. We studied about the asset properties. These are also known as the properties of transactions, or simply transaction properties. Asset stands for the atomicity, consistency, isolation, and durability. So these all are used for transactions, and all the transactions must fulfill these 4. Now we are starting with our today's topic. So the first thing is to know about the concurrency control. By concurrency control, we mean that if there are multiple concurrent transactions executing at the same time, then the coordination among such type of transaction is controlled, and this scenario is called concurrency control. The coordination of simultaneous execution of transaction in a multiprocessing database is known as concurrency control. Controlling concurrent transactions. By concurrent transactions, we mean that we have multiple transactions and all those transactions are executing at the same time. So controlling such type of transaction is called concurrency control. The objective of concurrency control is to ensure the serializability of transactions in a multi-user database environment. In case of multi-user database environment, we may have multiple transactions executing at the same time, or simply say that we may have concurrent transactions. So the main objective is to ensure that there is no conflict among these transactions, or due to the concurrent transaction no consistent data is coming, or there is no form of inconsistency in the database. In concurrency control, we have one important thing, that is simultaneous execution of transaction over a shared database can create several data integrity and consistency problems. If there are concurrent transactions, then it is obvious that some transactions may access a field at the same time, and such type of act may cause the issues with data integrity, or may make the data into inconsistent form. There are three main problems. The first one is lost update, the second one is uncommitted data, and the third one is inconsistent retrievals. Or these three problems are due to the concurrent execution of transactions. We will look into these three types one by one. So the first one is normal execution of transactions. Here we have transaction 1 and transaction 2. Two transactions are executing, and if we look into these two transactions, these are in serial form. The first one is executed and then the second one got executed. So there is no sort of conflict among these two transactions. The time slots are given to these two transactions and both performed successfully. Now, in case of lost updates, here the transactions are in a parallel fashion. Both are executing at the same time. In previous case, T1 got executed and then T2, and here we have these transactions in parallel mode. T1, then T2, T1, T2, T1, and T2. Now here we may get the issue of lost updates. Now look into this table. T1 read the quantity on hand, that is 35. So 35 is stored. Then T2 read the same thing and got 35. After that, T1 changed the value of quantity on hand. It added 100 with 35, and T2 changed the value of quantity on hand. It abstracted 30 from 35. Now if you look into this 35, it got changed due to T1 in the previous step, but T2 read it before this statement. Here at the time 2, T2 got it and it was 35, but before changing it, T1 changed it and made it to 135. So according to T1, the quantity on hand is 135, while T2 made it to 5. Now both updated the value, and it's not clear that what would be the exact value. If we make it in a serial fashion, then T1 read it here and made it to 135. After that, T2 got it as 135 and made it to 105. So these are in sequence, and both the transactions are giving us the correct value, and here both transactions are in parallel fashion and they have conflict, and both the transactions are giving us some ambiguous values. Then we have uncommitted data problem. Uncommitted data occurs when two transactions execute concurrently and the first is rollback after the second has already accessed the uncommitted data. Both transactions are executing at the same time. One made some changes, but after that rollback. But before rollback, second transaction got something and
made some changes on that uncommitted data. This violates the isolation property of transaction. We have already studied isolation property and acid properties. So here we have a normal sequence T1, T2. First T1 is executed, then T2. T1 got a value, made it to 135. It was 30, then 30, the 35 plus 100 made it to 135, but after that it rolled back. So the value is 35 again. So this one actually got cancelled. Also this one got cancelled due to rollback, and the previous value is maintained. T2 got this 35 and subtracted 30 from it and made it as 5. Both are in serial, so there is no conflict. But here T1 read the value as 35, added 100 and made it to 135. After that T2 read this value. Now with T2 quantity on hand is 135. But once this value is read by T2, after that T1 roll back this value to its previous state, and meanwhile T2 was using this 135 and it subtracted 30 from 135, so T2 made it as 105. Now if we look into this scenario, by rule T1 made it as 135, but later it cancelled it. So the value should be 35, but during this process, due to the concurrency, T2 got this 135 and processed it, even though this was reverted, this was rolled back to its previous value. So here we got a wrong value from T2. If you calculate this again, you will get something else, because the value of quantity on hand according to T1 would be 35 and according to T2 it would be 105. Then inconsistent retrieval problem occurs when a transaction calculates some aggregate function over a set of data while transactions are updating the data. If you remember, we have studied the aggregate functions. These are average, sum, minimum, maximum, count, etc. So some data may be read after they are changed and some before they are changed, yielding inconsistent result. We have some data here, and one transaction is going to change a value and another transaction got all these values and took, let's say, sum of these values, but after taking the sum, one transaction made a change, so the sum, ultimate sum, would be different from the sum of these values. Here we have two transactions, transaction 1 T1 and T2. The T1 is using an aggregate function for taking sum of quantity on hand. So this T1 will get the sum of all the rows under quantity on hand column, all the values of QOH in the table, and transaction 2 is updating two rows in the table, and in these two rows the quantity on hand values are changed. In one row the value is added with 10 and in second row the value is added with subtracted with 10. So here if we look into this select statement, it is just like taking sum of all these. So it would give us, let's say, 92 for these values. And if we look into these two statements, inside the T2, these would change these two values. In first statement 10 is added, and in second statement 10 is abstracted from the value. Now if we look into the sequence in the program, so here transaction 1 read the quantity on hand and it got 8, this first value. Then again read from the quantity on hand, got 32 and took sum of these two due to the sum function, so it got 40. So 8 plus 32, 40. After that T2 made some changes to a value in this table. It read this one value and made it as 25 by adding 10 due to this statement. T2 writes this 25, the new value, so this value is added in the list. So according to list, now this one is 25, and T1 read this one and this one till now. This one T1, this one is also read by T1. After that T2 read 25 and then 23. So T2 read this one now after this change, and also read this one, and due to sum, the sum of all these are calculated here, and due to the change this one is 65 and before it was 88. After that T2 took another value, that is 23. This one is already read by T1, but now T2 took it and made some change in it, made it to 13, and here after that 13 is written, means this one is now 13 even though it is read by T1. Then T2 committed, the changes are made. T1 now read the remaining two values, these are 8 and 6, and took sum of all these values, so ultimately it got 102. Now by rule it would be 92, but what happened here, T2 changed this value and T1 considered it. Here T2 changed this value but T1 did not consider it because before the change T1 already read it. So in this way the end result got corrupted. This is the example for inconsistent retrievals. So by concurrency control, we mean controlling the concurrent transactions. By concurrent transactions, we mean that there are multiple transactions executing at the same time, and these transactions may share some common data in the database. For example, we have two transactions executing at the same time and both are accessing same data field in a same data table. So this access may cause some issues and may make the data in inconsistent form.
to avoid such type of inconsistency is concurrent transactions must be controlled, and for that purpose we use concurrency control. So in concurrency control, we checked for the main issues due to the concurrent transactions in this lecture. These are the lost updates, uncommitted data, and inconsistent retrievals. We studied about these three problems, and we also checked some examples for these three problems due to concurrent transactions. The next video lecture we will start with the scheduler, which is a solution for these issues due to concurrent transactions, and this scheduler comes under the concurrency control.